I think Wednesdays wear red, right?
Yeah.
Yeah, Thursday's costumes, Friday's green and gold. I can't remember what Tuesday is. I'll have to look it up.
Oh,
I'll
heroes
post
and
it.
villains.
Heroes and
Friday's
villains.
green and gold, but football's on Thursday.
It is, but it's Halloween. I think we're gonna wear costumes. Are y'all wearing costumes to March?
Oh,
We
if my,
are
if my costume does come
in
in
section
on time.
theme.
I see
I
Walmart
don't like my section's theme, but everybody else wanted
You
it.
really will.
Okay, what's y'all's sections?
Adventure time. I just don't care about
Like, the thing is, it comes with a calendar, but they won't let me.
Adventure Time's amazing.
They won't let me.
it. It's better
No,
than what they wanted.
Well,
Originally,
usually
it was
it's
like half of them wanted and
I'm
half
still
hated,
playing.
which was
Yeah,
strawberry
if I can.
Oh, yeah, I'm glad y'all
If
didn't go
it-
strawberry
If
shortcake.
it comes in on time,
That'd be better.
Oh, you think so?
No, it would not. Adventure Time is definitely better than Strawberry Shortcake.
What was your time?
Okay, well, let's take a look at this one. All right, the correct answer is D. Let's talk about why. All right, so when we do implicit on this one, they've already got y isolated. So derivative of y is just dy dx, and then derivative of ln is a change. So it's 1 over 2x squared minus 3y squared times the derivative of the bottom, which gives you that 4x minus 6y dy dx. Now, we're trying to get dy dx by itself, and it is, but then there's all this other mess going on. So what I did first, so that I would be able to move that 6y dy dx, was multiply by 2x squared minus 3y squared. Seems like an unnecessary step, but it pulls it over there so that it's next to dy dx. And then that leaves me with no multiplication really kind of over there on that right-hand side. When I pull that 6y over, okay, because that 2x squared term is multiplied by the whole dy dx, that meant if I distributed it, they'd all have a dy dx, okay? So I can pull the minus 6y over and just put it in that parenthesis because it too has the dy dx, all right? So now I've got one single term times dy dx, then the non-dy dx term is by itself of 4x, okay? So now we divide again and we end up with 4x over 2x squared minus 3y squared plus 6y, which would be D. Okay, so implicit differentiation, the hardest part is the algebra. The calculus is pretty straightforward, right? We treat y like it's a function of x, so it's always composite. So the derivative of y is always dy dx. So we include that on the end, okay? Question about that one. That one's a little bit tougher just in the simplification, okay? And that's where you have to be creative when it comes to these. The good news is what we're going to do today, just kind of, we'll use implicit differentiation to prove some things that are true. And then we may or may not have to use it while we are doing the actual new derivatives we're going to learn, okay? So, which is good news. Take a look for me if you would. Here is your affirmation. Today is your opportunity to build the tomorrow you want. Okay, there you go. All right. I have to tell you, like, this is really, I'm like, oh my gosh, I have a whole nother semester of this to do. I'm going to do it though.
Nice.
I mean, there have to be enough quotes.
I have faith in you. It's good
You
so
could
far.
probably start reusing quotes.
I'm not going to reuse because I hope somebody has kept them all and would hold me accountable
You
otherwise.
can reuse next year. We won't be here.
Yeah, I won't tell next year.
Okay.
Okay. They won't know. So they'll just get the same
I have faith
ones.
in you. It's not
Okay.
bad.
All right. And I'm really enjoying my Canva. My husband's like, what's this $15 that comes out of our account every month for PayPal? I went, No. I was like, it's for school? Okay. He's learned he can't tell me no when it comes to school. All right. It's just so I can get all the cute pictures on Canva. All right. So we're going to, any questions out of your assignment from last night? I did post the answer key, but it was later. I'm sorry, it took me later in the day to post everything, Jacob. And the video had volume because I checked it.
Yeah, the video was pretty high quality. I'm sorry, I didn't watch it.
It's okay, but just know that there's a lot of really interesting conversation that takes place. We even talked to you at one point, so, okay. All right, so if you get bored this weekend, there's a little something for you. Okay, so today we're going to talk about derivatives of all exponential and logarithmic functions, okay? Because so far we've done e to the x and ln, right? Those are the only two we've done. So what is the derivative of e to the x?
E to the X.
E to the x. Isn't that beautiful?
Yeah.
Now, because we've learned about chain rule, all right, you're going to start seeing things written like this, and I just want to show it to you because x could be some function of something else. They will now do this, all right, and I just want to be sure I get it right. That dy dx is going to equal e to the u times du dx. So they'll take the x out and they'll put a u there instead because it could be a function of x. Okay, so just know that they will do that. Just means, hey, if you got a chain rule, do the chain. Okay, that's what that's saying. All right, but the derivative is still the same. And then likewise, we learned that the derivative of, bless y'all, is ln. Okay, so if we have the ln, y is 1 over whatever we're taking the ln of, and then the derivative of the inside stuff. So it could always be a chain. Right, so just using that new notation. Okay. So what we want to do today is talk about, well, what happens if we do like y to the 5x, y equals 5 to the x, y equals 7 to the x, okay? Something other than a base of e. And so we're going to use some things that we know about exponential functions, logarithmic functions, and implicit differentiation to figure that out, okay? And talk about why the e to the x formula looks a little bit different, yet is still the same, okay? So let's start with just a basic function, exponential. Let's call it y equals 5 to the x, okay? Y equals 5 to the x. And because I don't have a derivative formula for this just yet, right? Let's use some algebra to maybe get to something so that I could do implicit differentiation. All right, so how do I get rid of an exponential function? Anybody remember? What's one way we can do that? We can take a log, okay? And so we're going to actually take the natural log of each side. This is an algebraic equation, okay? And it's legal to do that. Laws of logarithms say we can do that, right? Properties of logs say I can do what with that x value that's up there as an exponent on that ln of 5 to the x. I could move it to the front, okay? So let's do that. All right, so ln of y equals x times the ln of 5, okay? Well, now let's do a little implicit differentiation, okay? All right, so what would be the derivative of ln of y? Yeah, times dy dx equals, now, ln of 5 is a coefficient, right? Okay, so what would be the derivative of x that has a coefficient of the natural log of 5? Derivative of x is just going to be 1, right? But we got to keep that coefficient, so what is it going to leave me with? ln of 5. Okay? Because that's just a number, right? Well, if I want to get dy dx by itself, what do I need to do? Divide by 1 over y, or in simpler terms, multiply by y. Okay? So we're going to multiply each side by y. So that's going to give me dy dx equals y times the ln of 5. Now, here's the thing. Do we have a definition for what y is equal to? Y is equal to 5 to the x, okay? So we're just going to replace it. We're going to substitute that y. So dy dx equals 5 to the x times the ln of 5, and that is actually the derivative, okay? Now, do we want to take the time to walk through that whole process every time? No, nobody does, okay? So let's think for a second about what we really did right there, okay? So we kept the original function and we multiplied by the natural log of the exponential function of the base, right? Think about e to the x, okay? If that holds true for all exponential functions, okay? If we think about e to the x, all right, so just a thought bubble down here. So if y equals e to the x, and we know that this exponential function says that we do dy dx, we would keep me original function. I'm a pirate, okay? Me original function, and then times the natural log of the base. Well, what's the natural log of e? It's just 1, okay? So that's why when we say the derivative of e to the x is just e to the x, but it follows the exact same formula. Okay, so that's where it comes from. We have to just kind of manipulate the algebra to get it to something that we can do implicitly, all right? So anytime we want to take the derivative of an exponential function, all right, it is that function times the natural log of the base, every time, okay? But for e to the x, it works itself out because the natural log of e is just 1. It's just e to the x, okay? Does that make sense? Okay. Y'all are very pensive. Makes me nervous. Okay. All right. Okay. So now let's do that same thing, but let's do the other direction. Let's start with a logarithmic function. Okay. Let's start with a log function. So we know that if I'm doing natural log, the derivative is 1 over whatever we're taking the log of. Okay, so let's see what happens when we change it. All right, let's take y equals log base 5 of x. Okay. All righty. Well, how can I get rid of that log base 5? Algebraically. Yep, put it back into the exponential form. Okay, let's put it back in the exponential form, which would be 5 to the y equals x. Well, lucky for us, we just learned how to do that derivative. Okay, so let's take the derivative implicitly and see what happens. So the derivative of 5 to the y would be 5 to the y times the ln of 5. Y is a function of x, so what do I have to include? Dy dx. And the derivative of x? 1. Okay. We want to get dy dx by itself. Okay. So let's do that. Stop it. So dy dx is going to equal 1 over 5 to the y ln of 5, right? Well, we don't want to leave that y in there because that's not how my function was defined to start with, right? But do we know what y is equal to? It's equal to log base 5 of x. So let's do some substitution. So dy dx equals 1 over 5 to the log base 5 of x times the natural log of 5. Well, that looks terrible. What is 5 to the log base 5 of x? It's just x. Okay, bless you. So what we got was 1 over what we were taking the log of, and then that times the natural log of the base. All right, think about your ln formula. Okay, so if y is the natural log of x, let's see if that works. Does dy dx equal 1 over x times, what's the base of a natural logarithm? E, and what's the natural log of e? 1. Okay, so that's why for ln of x, we just say it's 1 over x. Okay, the formula is the same for all bases, but we don't know enough calculus to prove that when we start. Okay, so now we do. All right, now we do. Isn't that awesome? All right, so here's what I want to do. Let's go back and let's just formalize what those derivatives look like. Okay, these are things that you should put on a flashcard, that you should put on your formula sheet. Okay, so jump back to the first page and let's do this. Let's go over here and let's put it in that formal notation. Okay, so up here at the top. If I'm taking, if y is equal to, let's call it a to the u. Okay, a being a number, u being a function of x. All right. Then dy dx is going to equal a to the u times the ln of a times du dx, meaning do your chain of your exponent. I didn't write that very good. Hold on. Swing, 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 swing. Scooch. Okay. Times du dx. All right. So that's your derivative formula for any base exponential function. Okay. So, same exponential expression times the natural log of the base times the derivative of the exponent. We're allergic to this today. Yes. Okay. It's all good. All right. Okay. And then the last one, all right, a logarithmic one. All right. So if y is equal to log base a of u, then dy dx, I call this the ulna formula. I think you'll see why. 1 over u natural log of a times du dx. Okay. So log is ulna. 1 over u natural log of the base. Okay.
Can you go back to the first one?
Yes, ma'am. So now we're just going to practice, all right? So there's only 2 new formulas to use today that we'll do all the calculus things with. Okay, so it's a short lesson, just to get used to practicing those. And again, you might have one on the AP exam, all right, that uses one of the, in some years we don't have to see it at all. So it just depends. It's one of those things I have to throw in because we're never quite sure. Okay, and it's good for you moving forward, for all you engineers in the house. Or if you go to Western and major in dance, you have to take calculus, which I think is interesting, and physics. But it makes sense if you're a ballerina, physics are important. Yeah, you'll turn quicker if you can know your physics. All right, we good?
Everyone should know physics, but like we're making dance students do like calculus physics.
I don't know. That's what they say. I'll never forget my student coming back and telling me that. I was like, you're kidding me. Nope, really glad I took it in high school. I was like, I had no idea. But every school's different. Every school's different. Okay, here we go. So let's take a look at this one. All right, finding a derivative. 8 to the 3x minus 1. It is an exponential function. It is going to require a chain rule because I have something other than x up there in the exponent. So let's walk through that derivative formula. So dy dx is going to equal, we keep that expression, 8 to the 3x minus 1, always the natural log of the base. And then the last thing you do is the derivative of the exponent. Okay, and what's the derivative of 3x minus 1? Okay, it's 3. Now, to me, the simplest way to write that is this. 3 ln of 8 is a coefficient. It's a number.
Pardon the interruption. All students that are attending the field trip with Ms. Russo and Ms. Hammock to TCAT need to move to the TPAC. I apologize, to TPAC. Need to go to the cafeteria at this time. All students with Ms. Russo and Ms. Hammock to the cafeteria.
I think they're going to see Sugar Skull down there, which would be really cool. Anyway. It's TPAC. It's a TPAC. I told y'all I got $39 tickets to Moulin Rouge.
I know what you mean.
Oh my God, it was amazing. I mean, like, anyway, I said, Rebecca, this is like, we've never sat, we always sit in the balcony, front row center of the balcony, and that's where our seats always were. And I was just like, it's a little bit of a naughty show, let's just be honest. But the costuming was outstanding, but I was up close and personal with their costuming. So I was like, whoa. Anyway, okay. But it was good. We want to go see Chicago. That's her and her daddy's favorite show. Did I tell you when Chicago the movie came out, it was on Valentine's Day, and I went to see it, okay? Now, my husband is a sports guy, okay? He's all sports. He tolerates all the things I love, okay? As I tolerate all the things he loves, because that's how it works, okay? So we're sitting there, and he's having the best time watching this movie, okay? And it's a musical, right? We get ready to leave, and he says to me as we're walking out of there, they really should make a play out of this, like on Broadway. And I said, baby, it is. Oh. So he has decided that when he and Rebecca, when Becca gets married, their father-daughter dance will be to something from Chicago. So there you go. All right. So I think it's that they both reach for the gun song, which is even weirder, but it's who they are. Okay. So let's look at this one. So find dy dx. This time we're going to do a logarithm that has a base of 5. And I have 3. Okay. 3 square roots of x. Now, I am going to rewrite that just a smidge because I have a feeling there's a lot of extra stuff I'm going to have to think about, okay, when I kind of get in there. Okay, so that's really my inside stuff. Okay, here we go. So a logarithm, right? Doesn't matter the base. We start with 1 over whatever's inside of there, which would be 3x to the 1/2. Okay, I'm going to write that for a second. Natural log of the base, so ln of 5, and then times the derivative of what was inside of there. Okay, and so what's the derivative of 3x to the 1/2? Negative 1/2. Okay, so that's what we've got there. All right, so 3 over 2 x to the negative 1/2. Now, we're going to be able to simplify some things here, okay? So let's just kind of look through this. What are we going to be, do you see anything coefficient-wise that's going to reduce? Because everything's multiplied. Well, I've got a 3 right here and a 3 right here. One's in the numerator and one's in the denominator. Everything's being multiplied. We can reduce those, okay? So that leaves me with x to the negative 1/2 over 2 natural log of 5 x to the 1/2, right? Can we combine those x's? Yes, okay? So remember, we're going to do positive minus negative, okay, and keep our answer where the positive one was. So 1/2 minus a negative 1/2 is 1. Okay, and it's going to stay in the denominator, so this is going to leave me 1 over 2x ln of 5. Okay, algebra is what makes that one tough. Oh, I bet that's Okie. Oh, just kidding, it's Dixie. Thank you.
Dixie.
It's Himmel. All right, so let's take a look at several more examples. All right, let's look at another one. All right, take a look at this one. Okay, dy dx. Find that if y is equal to log base a of a to the sine x. Okay, again, where are the numbers? There are nothing but letters in this problem. Okay. You cannot skip it. All right.
Said you can.
Well, I thought you said something else, and then that was not what you said.
No, I just saw it.
Yeah, I would simplify before I started, okay? Because if I know my logarithm properties and I'm looking at it, log base a of a to the sine x is just what? It's just sine x, okay? So y is equal to sine x, So what's dy dx?
Cosine.
Cosine x. Now, had you done the whole logarithm thing, it would have worked out eventually to cosine of x, but it would have taken a lot more algebra. Okay? So you've got to be diligent. You've got to really look at the problem and think, okay, is there anything I can do before I start that would make my life easier? And 9 times out of 10, it's going to be no. All right? But, sorry. Let me whop you with the lollipop. Right? But this one, it actually worked. All right? Which is nice. Okay. All right. Whew. Y'all okay? No, but it's all right. You're going to be. Okay, let's look at this next one. This is actually a calculator active question. Okay, I forgot to put your icon on there. All right, I think you'll see why in just a second. So it says, at what point on the graph of the function below does the tangent line have a slope of 21? Okay, so we're talking about a tangent line that has a slope of 21. What do I need? We need a derivative, okay? The slope of the tangent is the derivative. So let's do that first, okay? That I can't do with the calculator, so let's do that. So dy, I guess it would be dt, isn't it? Yeah. dy dt, because I got a t up there, is going to equal, all right? Let's do the derivative of 2 to the t. What's that going to give me?
That's a T?
Uh-huh.
Oh, it is. Oh, that's tiny, which you can.
It's tiny.
Oh my gosh. I thought there was 2 prime. T.
L and a t.
DT.
Okay. Well, everything's with respect, it looks like it's respect to t. Okay, because it's only got 2 variables, y and t.
Oh, yeah.
Okay. Do I need to take the derivative of t? It's just 1, so it doesn't matter, right? And then what's the derivative of minus 3? 0, okay? So we want to know, where is this equal to 21? Okay, that's what we're looking for, all right? Where is that expression equal to 21? Good thing it's calculator active, right? I don't want to solve that by hand. It's L and a 2, yeah, not T, thank you.
The tiny eraser.
I know, I was like, oh, got the tiny eraser. God bless it. Oh, that's a little bit better. Okay. I just make life hard for myself, don't I? It's all good. All right, so 2 to the t times the L and a 2, excuse me, equals 21. So let's go to our calculator. All right, let's go to y equals, and let's put that expression in there. I'm going to put 21 in the first one, and then in the second one, ln of 2, and then times, let's arrow out of that, times 2, and we'll just call it x. Okay, now, if I just hit graph in a regular window, am I going to see that horizontal line of 21? No, because what's the biggest thing we typically see in our window? 10, right? So when I hit graph, I'm only going to see that exponential function, all right? So let's go to our window, and let's make our y max 25. And we'll graph it, okay? All right, so I can see it. What do I need to find? Intersection. So second trace, that's number 5 on our calculator. Okay, so we'll say to the left, to the right, and then we'll ask it to guess. So what does it give me for my intersection point?
4.92.
Yep. Yep. Okay, and that's what we want. Okay. So at 4.921 is my intersection point. Okay? Alrighty. Okay. Now, it would be great if they left everything just normal, right? So if it's an exponential function, you have a number for a base. If it's a logarithmic function, you have a number for a base. But look what happens with this one. Okay? It's kind of the worst kind of combination, right? It's a little bit of everything, all right? We've got y equals x to the x. Well, if it's exponential, then x is the exponent, a number is a base. If it's a power function, x is the base, a number is the exponent. Well, I have neither of those things, okay? So all the things that we've done so far are not going to work yet, okay? So we're going to have to do a little algebra to fix it, okay? And the algebra we're going to do is take the natural log of each side, okay? So if you ever get a variable to a variable power or a log of a variable with a variable base, all right, we're going to take the natural log of both sides. So before I start, natural log of y is going to equal the natural log of x to the x. And here's why we're going to do it, all right? Properties of logs let me fix that exponent and get rid of it. Where does it come? Out in front, okay? So I get the natural log of y equals x times the natural log of x. We're going to be able to use implicit differentiation here, okay? We don't have an option, all right? This is the only thing because there's no formula for a variable to a variable power, all right? It doesn't fit the bill for anything we've done. So let's do a little bit of implicit, okay? So on the first one, derivative of natural log of y. One over y and a dy dx. Okay. On the right-hand side, we have x times natural log of x. That's a product. We've got to do product rule. Okay. All the things. So first, times derivative of the second, so 1 over x, plus second times derivative of the first, which would just be 1. Now, good news is it's going to simplify a little bit, which is nice. All right. What's going to happen to that? X times 1 over x. It's just going to become a 1. So I get 1 over y dy dx. It's going to equal 1 plus the natural log of x. So we're looking much better. Okay. We need to get dy dx by itself. So how would I do that? Multiply by y. Remember, you're multiplying that whole side by y. So I like to put it in parentheses so I don't forget. Okay. Now this is where we go back. My problem started with y by itself. Okay. It started out explicitly defined. So we want our derivative to be explicitly defined. Okay. So we're going to substitute just like we did a few minutes ago. What do we know y is the same thing as? X to the x. So dy dx is going to equal 1 plus the ln of x times x to the x. And that's my solution.
Okay, I mean, like the easy ones, like this.
Yes.
So when I get to this, I'm gonna change all of this and to this.
All right, so 3 or 4. So you got 2 out of 6, which is 0.33. Yeah, that's right. And then
I really messed up on this one because I did 0.256% and 5%.
Yeah, what do you mean by that?
that's 1/4. Okay.
Yeah, that's right.
Yeah, that's right.
No, maybe it's the calculator. I'll never believe the calculator.
So, like I said, if we end up with a function or an expression that's in some kind of weird version, all right, that's not like, it doesn't fit any rule, okay, you're probably going to have to do implicit in some way, shape, or form. Okay? These will be few and far between as well, all right, but it's always possible. Okay, so but you can count on there'll be one on the test. Okay? All right, there'll be one on a test.
Thank you.
You're welcome. Just try to be honest. Okay? Just so you know, put a balloon on it, as my history teacher used to say. You're going to want to study that one. Okay?
I think they should
My
not
history
put that
teacher
on
just called me a sack of trash.
Why would I call you a sack of trash?
No, it's just that's what my history teacher.
Oh. Van Dyke.
Yeah. It's a term of endearment.
Oh, okay. Like heifer?
Yeah,
Oh, okay.
sure.
Sure. All right, I want to do two more. One more that's calculator active, and then one that's just, again, just going to force you to problem solve a little differently, okay? Because really the only new thing is the two new rules, all right? Himmel, do you have a question? You're really
No.
studying. I just want to make sure you're good.
Have you ever asked a question in class?
Yes.
Probably.
I'm pretty sure you asked one last year for sure. Okay.
I just don't know why. It's just it don't.
Okay. All right, let's look at this one. Okay. So the spread of a flu in a certain school is modeled by this equation. Okay, P of t equals 100 over 1 plus e to the 3 minus t, where P of t is the total number of students infected t days after the flu was first noticed. Estimate the initial number of students infected with the flu. Okay. What does that mean?
How many have flu at T equals 0?
How many people have flu at t equals 0? Does that require any calculus? No. Okay. How many people have the flu at t equals 0? So we're going to let t equal 0, and we're going to plug that in. So I want p at 0, which is going to be 100 divided by 1 plus e to the 3 minus 0. Okay. Or 100 over 1 plus e to the 3rd. Okay. We would use a calculator to get that answer. All right. Somebody do that for me and let me know. Okay, let's call it 4 people. Okay, although sometimes I feel like 0.72 of a person. Okay, so we're going to call it 4 people. Now, the next question. How fast is the flu spreading after 3 days? What is that asking me for? A rate of change. Okay, it's asking me for a rate of change. And if it's asking me for a rate of change, that is the derivative evaluated at what day? 3. Okay, so this is where we're going to use that inderiv function on our calculator, math 8. Okay, math 8. We're going to use the calculator to help us get this answer. Right? So let's jump over here. All right, so we'll go to math. Number 8 is inderiv. Now, the function's funky, but it's okay. Alpha y equals, we're going to put it in there, 100 over 1 plus e, so second ln, to the 3 minus x. We're going to arrow over there for x equal to 3. What did you not like? Oh, I deleted something. Hold on. Math 8. Nope, not that. Clear. Math 8. Maybe I need parentheses right there. 3 minus x, close my parenthesis, add x equals 3. See if it likes that. There it is. Okay. Now, that's my rate of change. Okay. That's how many people are getting infected at day 3. All right. 24 point, we're going to round how many places? 3. If it said the nearest whole number, we would say 25. Okay, but because it didn't, we're going to always take 3 decimal places. So let's just call it 24.999. What are my units going to be? People per day. Okay, so units are important there. Okay, that's our rate of change. That implies a derivative. Okay, question about that one?
Would they still count it through a 25 instead of
Probably because it was all the 9s would cause it. Okay, but rule of thumb, 3 decimal places. So unless they tell me to round, I don't. And if I need, like, even though that would round to 25, I would truncate because that's allowed as well. And I would just cut it off at 3 decimal places. Just so that I meet that requirement. It's hard to know. If it's multiple choice, you'll know for sure. Because it'll either have all the decimal places or it'll have rounded, nice, pretty answers. So, okay. All right, then let's look at this one. This is the last one we're going to do. Okay. Just because it's interesting. So a line with a slope of n passes through the origin and is tangent to the graph of y equals ln of x. What is the value of m? Okay. And at first I might think, well, how in the devil am I supposed to know? Because there's not a single number anywhere in that problem. Okay. But maybe that means we're going to get an answer that's not numerical, or maybe it's an answer that will work itself out to be numerical in some way, shape, or form. Okay, so let's just kind of walk through what they're telling me. The function y is natural log of x. Okay, and natural log of x graphs to look something like this. Okay, so this is y equal to natural log of x. Right? There is some point on that graph, okay? I don't know that point, so I'm going to call it A, right? Where the tangent line is going to pass through the origin and has a slope equal to m, okay? Make sense? Okay. Now, let's see if we can name that point. All right. Let's name that point where this is happening. Okay. So if the x value is a, what's the y value going to be? ln of a, because it's on that y graph. Okay. So that's my point. All right. We're talking about the slope of that tangent line. All right. So, do I have now 2 points on that tangent line? I do. Okay, I have 2 points on that tangent line. So, could I find the slope? Yeah. Okay, I could find the slope. Do it the old-fashioned way. Change in y over change in x. So, ln of a minus 0 over a minus 0. So, my slope is ln of a over a. Does everybody agree with that?
Yeah.
Yes. Okay, now, that doesn't help me to get a value. Okay, because that's all still, I don't know where A is, right? But would that slope be the same thing as the derivative evaluated at A?
Yeah.
Yes, because that is the slope of my tangent line at A, okay? So let's take the derivative. What is y prime? It's going to be 1 over x, or we're calling it A. All right, and so now I know, all right, that these 2 things have to be equal. Okay, so ln of, there's too many letters, ln of a over A equals 1 over A. It's like they're related, okay? Well, if the denominators are equal, what does that mean is true about your numerators? They're equal. So the ln of A is going to equal 1. Okay? What's A have to equal? E, okay? So A is equal to E. Now, it didn't ask me for A, though. What did it ask me for? It asked me for M. Okay, it asked me for M. So now that we have found that A is equal to E, okay, M is equal to 1 over A, or ln of A over A.
Hello teachers, I'm sorry for the interruption. This is the last call for canned food drive. Again, this is the last call for canned food drive. Thank you.
And there's my value, okay? That's what it was asking me for. What is the value of M? It's 1 over E. Whoo! Y'all, that's good stuff right there. Okay? So that's where we have to understand that we really had a funky, fresh system of equations right there. Okay? That's really what we had. We had two different situations that we could find mathematically two different ways. Okay? The derivative is the slope of the tangent, which has to be M. Okay? So this is the slope of the tangent. And so is that. Okay? They are the same thing. Okay? And so we can solve for A, right? Because of that relationship, A has to equal E, because that's ln of E is the only thing that equals 1. All right? So then to find the value of M, I use the simpler equation, which is this one. Right? So it's 1 over E. That's good stuff. Oh, that makes my brain really work. Okay. Do what?
Like, I understand, but she's like,
It's a lot. There's one in your homework that's like it, so you can try.
oh.
Okay? You should try. Trust me, you should try. Okay. All right. Well, I'm done for today. Okay? I just wanted to suck all the wind out of your sails right here at the end and then, give you some time to meditate on it. All right. That's okay. I can breathe. I can give you a power whoosh. Blow it back in. That's right. Okay.
How did ln of A over A equal 1 over A?
Okay. So ln of A over A is the slope of the line using the slope formula.
Oh, okay, got it.
Okay. And then 1 over A is the derivative
Yeah.
at that point. So they're the same. Good job.
I want my numbers, but.
You got your numbers.
E's a number.
Yeah, and we had to hunt many teachers down to find out what that is.
Do you have any more problems like this other than on the homework?
We can play Wii Sports.
No, and you don't want me to make one up because I will make a crap show out of it. Yeah, these are the problems I don't make up. I go to somebody else who's made them up. Type one into ChatGPT and see if it'll give you one.
Oh my god.
So we're gonna bar
Okay.
Yeah, only seniors.
What are y'all talking about?
we made a golden, well, they made a golden discovery
Oh.
yesterday.
Oh, you guys found the Wii U?
Yes.
It's been there. The Wii's been there.
Yeah, but
And also we closed the door so we could hear it.
You guys all played it.
No, there's a pet Also,
Not found out.
All right. You have a quiz Monday on 3.2. Let me look at it real fast. So you have a quiz Monday on 3.2. It is short. Okay, so I will cover 3.3, which is also short afterwards. Okay, so we'll do a quiz and a lesson on Monday.
Sounds groovy.
Yep. All right, and then Tuesday we'll do 3.4, and then Wednesday we'll do 5 and 6. Then we'll review the last 2 days of the week, and then we'll take your test the next Monday. Okay, then you'll have Tuesday off, so you'll get a day to pray over it. And then you can come back and we'll do corrections the next day.
Awesome.
Okay, after election day.
Sounds like a plan.
Right? So let me see, it's, I think it's 5 questions on the,
Is it really you know the unit?
yes.
I mean, it's good to know. I miss my numbers, but it's still good to know.
We should have done Cal PC. I wanna see what that's about.
No.
I can barely handle AB, Hamill.
Hey, and just as you're welcome, what we did today is not on the list.
Okay.
Okay, so it's just implicit.
Okay.
Okay, it's just implicit, you're welcome.
I'm still gonna do that over this.
Oh yeah, I gotta wrap it up.
All right, do your wrap up.
Does this wrap up not signify very much?
That was my mind trying to do that last one over, and just did.
The inside.
But it's not an LN.
It still counts.
No.
It'll be fine.
It'll turn into a.
Oh yeah, the log is also an element. And then.
Oh, no.
So the denominator of it, so it's much the most one divided by element times everything.
Mhm.
And then do multiply by.
So it's gotta be a log.
Y equals W and
Not
then
a denominator.
Let's check it.
I think that's the most evil wrap up you've given us.
You think so?
Does it not